Okay. So we've been talking about this whole accuracy and precision and measuring. Try this again. All right. So up to this point, we have been talking about measuring and accuracy and precision in measuring and how to report numbers and what is the appropriate level of precision to record a certain measurement in a lab. So now we're going to get into significant figures. And this comes into play once you start calculations. So once you do a calculation, your calculator spits out all of these numbers as an answer. And so if you record those numbers just exactly as how your calculator tells you, you run the risk of giving a more precise calculation than what your measurements were in the first place. And we don't want to do that. So when we talk about significant figures, we're talking about recording your calculations in a manner that is appropriate. So at the end of this lesson, you should be able to determine the number of significant figures in a number. You should also be able to measure and round calculations to an acceptable precision. So your summary questions: what are the rules to determining the number of significant figures in a number? How do you know where to round a number that has been added or subtracted? And how do you know where to round a number that has been multiplied or divided? As we've discovered when we measure data, there is some degree of uncertainty in our measurements. The amount of uncertainty depends on what tool we are using to do the measuring. Scientists use significant figures to show how precise a measurement is. So significant digits in a measurement I wanted to take that out. As we have discovered when we measure data, there is some degree of uncertainty in our measurements. The amount of uncertainty depends on what tool we are using when we are doing the measuring. So scientists use significant figures to show how precise a measurement is. And we call those significant digits. So significant digits in a measurement include all of the known digits plus one estimated digit. So this quote right here: to a mathematician, 21.70 and 21.700 are the same. But to a scientist, that second number is more precise and indicates to the reader that a different tool was used than the one in the first number. Okay, so in that second number, we used a more precise measuring tool than we did with the first number. So they're not quite the same thing. Even though they have the same value, they are not the same thing. So to a scientist, so to a mathematician, 21.70 and 21.700 are the same. They have the same value. But to a scientist, 21.70 centimeters and 21.700 centimeters is not the same. 21.700 centimeters to a scientist means the measurement is accurate to within 1,000th of a centimeters. The 21.70 would be accurate to within 100th of a centimeter. So they are two different values. So significant figures are used to convey to the reader the degree of precision that was used to measure the data. The last digit represents the uncertain or estimated part of the measurement. Now, things start to get a little dicey when we add calculations into the mix. You've probably noticed that a calculator will spit out as many numbers that will fit on the screen. Are all of those significant? Probably not. One key thing to remember is that you cannot have more significant figures in your calculated answer than you do in any of your measurements. This makes sense, really, right? Your measurements can't magically become more precise just because you used a calculator. So how do you know how many significant figures we have in a given calculation? Well, there are some rules. Rule number 1 is the easy one. All non-zero numbers are significant. So if you have the number 123, you have 3 significant figures. They are all non-zero numbers. They are all significant. If you have 45.6789, those are all non-zero numbers. They are all significant. So you have 6 significant figures. So now once we start getting into zeros, that's where it gets a little tricky. Zeros located between non-zero digits are significant. They count. 12.003. Okay. Those 2 zeros are between non-zero numbers. They are significant. The 1, the 2, and the 3 are also significant. So all of the numbers in this number are significant. So we have 5 significant figures. Now, what about this one? The 4, 5, 6, 7 are significant because they are non-zero. The first 0 is between the 5 and the 6, and the second 0 is between the 6 and the 7. That last 0, however, is not between non-zero numbers. So only the first 2 zeros here are significant. So the 4, 5, 0, 6, 0, 7 are significant in this number. So you have 6 significant figures. The trailing zeros, those at the end, are significant only if the number contains a decimal point. Otherwise, they are insignificant and don't count. So 123.400, there is a decimal point. So those 2 trailing zeros are significant. So all of the numbers here are significant. So we have 6 significant figures. Now on this number, we have 567,000. There are 3 trailing zeros, but no decimal point. So those zeros are not significant. Only the 5, 6, and 7 are significant. So there are 3 significant So there are 3 significant digits in this number. Now, what about this one? We have 901.230. Now, that first 0 is in between 2 non-zero numbers, so it is significant. The trailing 0 is in a number with a decimal point, so it is also significant. So in this number, all of the numbers are significant. Now, sometimes you will see a number written like this. Okay, so you have a decimal point, but nothing after the decimal point. What that decimal point represents is that 0 has been measured. So when we measured it, that arrow fell right on the 0 line. So a decimal point at the end of a number with zeros at the end indicates that those zeros have been looked at and they're not just a placeholder. So the first 0 is in between 2 non-zero numbers. The trailing zeros are in, are in the trailing zeros are in a number with, me fix that. Okay, so this number is a little bit unique because there is a decimal point after the 0. What this means is that those two trailing zeros were actually measured. So if we go back to our pencil from the last lesson, if that pencil had landed right on the 0 line, we would have included those zeros. So that just indicates that those two zeros have been measured, and so they are therefore significant. They're not just placeholders. So the 0 between the 5 and the 6 is between two non-zero numbers. That's significant. The two trailing zeros are in a number with a decimal. They are also significant. So we have 7 significant figures in that number. All right, now let's say we have a 0 to the left of the first non-zero digit. These are going to be placeholders and are insignificant. So for example, 0.123. That 0 is just holding a place. It doesn't really mean anything. So it's to the left of the first non-zero digit. So it is not significant. So the only numbers that are significant here are the 1, 2, and 3. So we have 3 significant figures. Okay, so same thing with this one. We have 0.00. Those are to the left of the first non-zero digit. So those first 3 zeros are going to be significant. Now, what about this last 0? This last 0 is a trailing 0. That trailing 0 is significant because it's in a number with a decimal point. So the first 3 zeros are not significant, but the last one is. So in this number, we have 4 significant figures. Now, what about this one? This one has a lot of zeros in the front, but they're all to the left of the first non-zero digit. So none of those zeros are significant, but the 7 is because it's a non-zero number. So there is 1 significant figure in this number. So take a second. How many significant digits are in the figure? All right. Pause your video. Write down how many significant figures there are in the following numbers. All right, so in this first one, all of those zeros are to the left of the first non-zero number. They are not significant. So there's only 2 significant figures here. In number 2, all of those zeros are significant. You have those first 3 in between 2 non-zero numbers, and the trailing 0 is in a number with a decimal. So we have 6 significant figures. Number 3, we have trailing zeros, but no decimal point. So only the 2 and 5 are significant. Number 4, we have trailing zeros with a decimal point. So both of those zeros are significant. So we have 4 total significant figures. In number 5, all of the zeros are to the left of the first non-zero number. So only the 1 is going to be significant. And then number 6, there are no zeros, so they are all significant. You have 4 significant figures in that last one. All right, now, once you start doing calculations, it gets fun. So when you're adding or subtracting, your calculated value will have the same number of digits to the right of the decimal point as that of the least precise quantity. So you're looking for the fewest digits on the right of the decimal point. So if we're going to add these numbers together, we have 13.05, 309.2, 3.785. When we add those together in the calculator, we're going to get 326.035. The second number, this 309.2, the uncertain digit is in the tenths place. So that is the least precise measurement that we have. So when we round our answer, we're going to round to the tenths place. Okay? We are not going to include that 3.5 on the end. Oops. We are not going to include that 3.5 on the end. So when we report our answer, we're going to record 326.0. So what about this calculation? In our first answer, we don't have a decimal point, but in the second one, we have 1. So where are we going to round to? We're going to round so that we do not have a decimal place. So 767 is going to be our answer. What about this one? Our first number has 4 decimal places, and our second number has 2. So 2 is the least precise. So we are going to round our answer to 2 decimal places. Rules for multiplication and division are a little bit different. What you're going to do is you're going to use the number of significant figures in the final calculated value will be the same as the quantity with the fewest number of significant figures that you used in the calculation. So you're finding the quantity with the fewest number of significant figures. So let's look at this. If we look at that first number, we have 12,340. How many significant figures does that number have? That's a trailing 0 with no decimal point, so it's not significant. So the first number has 4 significant figures. The second number has 2. Oops, there we go. So we are going to round to 2 significant figures. So 55,530 rounded to 2 significant figures becomes 56,000. In this next one, when we multiply it out, our calculator is going to tell us we have 8,377.626. So in the first number, we have 5 significant figures. That last 0 is trailing, but there's a decimal point. So there's 5. That second number, there's 4. So 4 is the least number of significant figures in the numbers that we're calculating. So we're going to round our answer to 4 significant figures. So instead of 8,377.626, we're going to have 8,378. Now this last one, when we multiply it out, we get 0.6985047. The first number has 5 significant figures. And the second number has 3. Remember, those zeros to the left of the first number are not significant. So we're going to round our number to 3 significant figures. So we're going to have 0.699 instead of 0.6985047. All right, pause your video, calculate these out, and give me the answer with the correct number of significant figures. First one we're multiplying. The lowest number of significant figures in our calculated numbers is 3. So we're going to round to 3 significant figures. In number 2, we're dividing, and we have 4 and 2 significant figures. So we're going to use the least number. So 2 significant figures. We will end up with 25. Number 3, we are adding those together. So remember, this is the least number of decimal points, and 6 is the least number of decimal points. So we're going to round our answer to 53. Number 4, we're subtracting. So again, least number of decimal points, which is through the 10th place. So in this case, we're going to round to the 10th place. And then in number 5, we're multiplying again. So we're going to use the least number of significant figures. 0.21 has 2 significant figures, 3.2 has 2, and 100.1 has 4. So the lowest number is 2. We are going to round our answer to 2 significant figures. All right. So you're probably thinking at the beginning, this didn't sound so bad. There's just several rules to remember. There's several things that you have to keep in mind. Can you, for one, determine the number of significant figures in a number? And then, once you calculate a number, can you round it to the correct precision? So in your summary, answer those questions.